put this question here because it's good practice for your test on Thursday. Just remind you a bit of geometric sequences and also a bit of logs. I mean, and logs, you can see it's coming up everywhere, whether it be in this part of the course or like you've been doing recently with some of the function work as well. So logs, logs and exponentials, it's going to come up everywhere, especially in second year. So really good to get used to those sorts of questions. Now, firstly, we're told the third term of a geometric sequence is 8/3, and the sixth term is 64/81. Now, remember, the general term in the geometric sequence would be defined as a times r to the power of n minus 1. What this means is then, if I want to find the third term would just simply be ar squared. So ar squared, therefore, is your third term, and you're told that your third term is 8/3. Ar to the power of 5 would be your sixth term. Your sixth term is 64/81. If I call this equation 1 and this equation 2, and I do equation 2 divided by 1, then I would simply end up with ar squared equals 8/3. Make sure that you do your division the correct way around. Okay, now the reason why I'm setting it up like this is because if I want to find the sum to infinity, I need to know what a is and I need to know what r is. So I'm going to find what a and r are first by setting up these two simultaneous equations and then solving from there. So once I get to this point here, sorry, that should just be r cubed. Sorry, I'm looking at the wrong bit there. Completely ignore that step. I'm looking at the next bit that we need to do. Right, so we do equation 2 divided by equation 1. So a divided by a, the a's are going to cancel. R to the power of 5 divided by r squared, that gives you r cubed. And then your 64/81 divided by 8/3, that's going to give you 8/27. So we can just therefore find that r is going to be 2/3. Sub that back into either equation 1 or either equation 2. I'm sure you can all do that, so I'm just going to give you the answer here. And you get that a is 6. If you want to find the sum to infinity, we just use that formula, a over 1 minus r. So we do 6 over 1 minus 2/3. And that would just be 18. Right, so just to recap there, we didn't know what a is the first term, remember, in geometric sequence, a is the first term, r is the common difference. Common ratio. Common difference is for an arithmetic sequence. For a geometric sequence, you have a common ratio, what you have to multiply by to get to the next term. So our first term is 6, and the common ratio is 2/3. So if you want to find that, you can check it because the 6 times 2 to the power of 2/3 to the power of 2 would be 8/3, which is your third term. Then this last question says, find the minimum number of terms in the sequence for the sum of the series to exceed 17. So I'm just going to give myself some room to do this. I'm just going to rip this out. But I will just put up here that r equals 2/3 and a equals 6. Now, to find the minimum number of terms of the sequence, I'm going to need to use my other formula here that's given. Okay, you will get given this in your tests next week, and you will also get given this in the exam. So what we're going to do is plug in that Sn equals 17, and what we're going to try and do is find what n is. So we're going to find out if a is 6, r is 2/3, n is what we're trying to find. Then we've got 1 minus 2/3. And then we've got this sum of 17. Now, what I need to do now is start to rearrange this to find n. So the goal here is try and get n on its own. So firstly, on my denominator, I've got 1/3 times both sides by 1/3 and then divide by 6. This will give you 1/2/3 to the power of n equals 17/18. From there, what we're going to do next is we're going to take 1 away and we're going to divide by -1. So take 1 away, divide by -1, we get 2 over 3 to the power of n equals 1 over 18. Finally, what we do is, because we've got a missing power we want to find, so we're not going to do this by trial and error, okay? We've got a missing power we want to find. So what I'm going to do is use logs here. So if I do log to base 2 over 3, and then put the 1 over 18 there, then you can just put that in on your calculator using that log button. You get 7.13, but we need the minimum number of terms for it to exceed 17. So don't just round down here to 7, because 7 terms won't be enough. 7 terms would give you a number that was less than 17. You need a number that's greater than 17. So you'd need 8 terms. So just a type of question that you might want to practice ahead of the test next Thursday. As I put there, make sure you filled in that form if you haven't already. And we'll say I've posted this morning some practice questions. Gavin's posted that sequences homework. So remember, this is not just sequences, it's proof as well. Go through the questions. I've put lots of advice on there as to how I would tackle them. But just do the practice, because it ultimately is going to be what helps you get better and improve your grades. Okay, but please do ask for help if you're not sure on anything that we're doing here. Right, so then back on to functions. So this is the last bit to fill in the P09 handbook. Apologies again, it's kind of jumped over the kind of place a little bit. But we're going to just do these couple of examples today. So I've spent a bit of time on that start question just because there's only a couple of examples to go through this morning. And then that'll be it. Pure Handbook 9 done. Now I'm going to start off with this example 5 here. So we're given this function 3 times the modulus of x minus 1 and then take away 2. We're going to sketch that graph first. So what I would do is do this in stages. Firstly, I would just draw what the modulus of x minus 1 looks like. So hopefully you've had lots of practice recently on drawing modulus graphs. Think about what x minus 1 would look like. It'd have a root at x equals 1. It'd have a y-intercept at y equals -1. But when you take the modulus, you're going to reflect that in the x-axis, so it would look like this. So this is the graph of y equals the modulus of x minus 1. Next thing I would do is think about, and you might want to do this in less steps if you want to, but it's recommended if you do struggle with drawing graphs, just break it up into different stages. So then think about what 3 modulus x minus 1 is. Well, you're not affecting the x there, you're affecting the y value. So your root is still going to be at 1, but all your y values are going to get multiplied by 3. So now you're going to have an intercept there at 3 instead. Finally, what will happen for the last bit is you're going to take 2 from every y. So this graph just drawn here, that's y equals 3 modulus of x minus 1. Okay, basically think of that as a stretch of scale factor 3 parallel to the y-axis. Now I'm going to draw y equals 3 modulus of x minus 1 and then take away 2. So I just need to take away 2 from every y value. So this intercept here of 3, that now becomes a 1. This minimum value here, okay, so the before this, it was at x1, y0. X will still be 1, but now the y value will be -2. And because it's sketched, I should show my intercepts. So I'm going to need to find where it crosses the x-axis. So to find out where it crosses the x-axis, I'm just going to do this above here. I need to find these 2 solutions. One of them, the x minus 1, hasn't been reflected. And for the other solution, the x minus 1 has been reflected. So the firstly, I'm going to solve this as if the modulus wasn't there. And then secondly, I'm going to solve it to find this solution on the left, but times that x minus 1 by negative 1, so you get 1 minus x, because that's going to find my solution that has been reflected. When I solve these, because I've not got much room, I'm just going to put down the answers here. You've got x equals 5 over 3 and x equals a third. So those are going to be my roots. So that is part A. Part B is nice and quick because I've got a nice detailed sketch here, and that's just the range of this function. So if you look at the graph here, you can see that I've got this minimum point here of 1 minus 2, and you can see that it's just going off to positive infinity for any other value as x gets bigger or as x gets smaller from the 1. So the range is just simply going to be f of x, because I'm describing my range, is greater than or equal to negative 2. Okay, the lowest value, the smallest value of y is negative 2. So if you look at the graph, it's only ever getting bigger than that. As you can see, when you've got the sketch, you've got all the key points shown on there, it's nice and easy to see. Last thing I've got to do is solve the equation 3 modulus of x minus 1 take away 2. Okay, that's your f of x equals a half x plus 3. So yeah, again, do a sketch because then you will see where your solutions are. So firstly, I'm going to draw my f of x again. And then I'm going to draw the line a half x plus 3 here. So for my f of x, so this is the f of x here, I've got that y-intercept of 1. For half x plus 3, now with x minus 1, you've got a gradient of 1. With a half x, you're going to have a gradient of a half, so it's going to be shallower than the f of x graph, but it will start above here on the y-axis because the y-intercept is 3. So it's just going to look something like this. And you can see that one of your solutions is going to be negative, one of them is going to be positive. So this is just a half x plus 3. So this enables us to see where my two solutions are. Firstly, I'm going to find this green solution. So there's been no reflecting. So I'm just simply going to solve a half x plus 3 equals 3 modulus of x minus 1. Take away the 2. That's just your f of x. And yet again, to save a bit of time, I'm just going to tell you what the final answer would be. And that's just simply 16 over 5. Okay, so just remember, sorry, I shouldn't put the modulus there. Let's just put this bracket because we know it's positive. So just solve that, expand it out, collect all your x's, solve it. You should get 16 over 5. For the solution in blue, now the half x plus 3, don't take negative of that because that hasn't been reflected. But if you look at that blue solution there, the line of x minus 1, that has been reflected. So you need to solve 3 times 1 minus x. So you need to make that bit negative and then take away the 2. So when we solve that, we're going to get x equals minus 4 over 7. And those are your two solutions. And it makes sense looking at your graph. You've got a positive one there for the green one, and you've got a negative one there for what's in blue. If you've got any questions, please let me know. And we're just going to go to our final example. So just 2 examples today, quite long examples, but just the 2 for today. So we've got another function here, 6 minus 2 mods of x plus 3. So we're going to sketch the function, state the range, and there's a couple of other questions we've got to do after that. Kind of brings everything that we've been doing over the last couple of weeks together. Firstly, what I'm going to do is sketch the modulus of x plus 3. See, again, we should be all well practiced in doing graphs like this. Think about what x plus 3 would look like. You'd have a y-intercept at 3. You'd have a root at -3. Now, normally that would, if it's just x plus 3, it would continue going below the x-axis, but of course, modulus, we need to reflect it. Then I'm going to do -2. Okay, do the multiplication first. Think about BIDMAS. So you're timesing all your y values by -2. Okay, you work out modulus of x plus 3 first, and then you times your y values by -2. It's just a bit like when we do a transformation. If we, let's say, have g of x, and then if we were asked to find -2 g of x, then what we would do is multiply all those y values by -2, or think about it that you times all your y values by 2 and then you reflect it. So your root of -3 would stay as it is, but your y-intercept, well, you've got to do 3 times -2, so that would just be -6. So you still got the x hasn't changed, it's still -3, but now you've got -6 as your y-intercept. Finally, I'm going to do modulus of x plus 3, -2 times the modulus of x plus 3. So all I've got to do now is just add 6 to all my y's. Yet again, this is not going to change your x's because you're going to so you're going to put in modulus of x. You do that part first, and then you're going to times it by -2, and then you're going to add 6 to it. So yeah, again, just thinking about what happens to your y values, or these key points we've got here. So this -3, it was -3, 0 before. So the x is going to remain a -3, but you're then going to add 6 to it, to the y value. So that's going to be -3, 6 now. Before it was -3, 0, now it's -3, 6. And then if you look at your 0 minus 6 value, well, it's still, the x is still going to be 0, but the y value will now be 0. So it's just going to go through the origin here. And also, you would now have this intercept here at x equals -6 as well. Okay, you could do that by just simply subbing in y equals 0 and then solving it. And then we just need to state what the range is. So again, look at the graph, look at that key point here that I've just highlighted in green. The highest value of y is just going to be 6, so it's only ever going to be 6 or lower. So we just say that f of x is less than or equal to 6. Okay, 6 is the highest value, and it can only be that value or lower if you look at the graph. Make sure you got greater than, sorry, less than or equal to here. For part B, you just have to, it just says, by considering graph, give a reason why the inverse of f does not exist. So if you look at this graph, now if we get a ruler, we can see that there's many places here where many values of x go to the same value of y. So if you just take where I put my ruler here, you can see that there's 2 values of x that would give you the same value of y. If you just, for a very simple example, take the x-axis, you can see that when x is -6, when x is 0, both of those values give you y equals 0. So more than one value of x gives you the same value of y. What this means is it is many to 1. And to be a function, sorry, for it to have an inverse, it needs to be a one-to-one function. So it is many to 1 and not 1-to-1. So therefore, the inverse does not exist. It could exist if we restrict the domain. So if we said x is greater than or equal to -3, that would be fine. It would then have an inverse. If x was less than or equal to -3, yeah, again, that would be fine. It would then have an inverse. But at the moment, it's many to one, so it doesn't have an inverse. Finally, we're going to solve this inequality if f of x is greater than 5. So I would look at my graph here, and I'm just going to draw a line here and say that this is the line y equals 5. And because I'm solving this inequality, basically I'm looking for anything that's above this line, okay? All these values here are greater than 5. So I need to find my critical values. Remember, my critical values are going to be where it equals exactly 5. So I'm going to find the critical values. So what I'm going to do is set this equation to 5. So for this solution that I'm going to put in green here, that hasn't been reflected. Okay, that is just your normal x plus 3 line. So I'm going to start with this one first. And when I solve that, I will get x equals -5 over 2. To find the other critical value, again, I'm assuming that we're all okay with solving equations like this. To find the one that I'm highlighting in blue, this is where we have reflected this line. So I'm just going to simply change that -2 to a +2, because I want to treat that x plus 3 as minus x minus 3 now, because it's been reflected. So to find that solution, just make that +2, solve it, and we'll get -7 over 2. So in terms of your answer, look at your graph. You can hopefully see that for the values of x that you need to put in that give you a y value that's 5 or more, the x has to be between -7 over 2 and -5 over 2. So your solution is just simply going to be -7 over 2 is less than x, which is less than -5 over 2. Make sure you get that inequality the right way around, by the way. Some people sometimes get that incorrect and it wouldn't make sense the other way around. So make sure you get that inequality the right way around. Okay, so that would be your solution, just between -7 over 2 and -5 over 2. And looking at your graph, that makes sense. It's just going to be between two numbers, and you know they're both going to be negative. Okay, if you've got any questions, pop in the chat. But that is the end of Pure Handbook 9, and also pretty much the end of the normal live lessons. Okay, so thanks for sort of participating in this. It has been different. It's not obviously been ideal, but hopefully we tried to make the best of a bad situation. But thank you for all your participation in this. Next week, it's all about focusing on your test. So make sure that you've done the Microsoft form. If you haven't, just confirming your attendance to that test, and let us know if there's any problems there.